What's up, guys, and welcome back to the tutorials. We're going to continue with module 4 like we did last time, just pick up where we left off. It looks like we're showing on the in operator. So here we go, let's start it. Okay, the field genre in our table has the list type. Let's try to figure out how to filter the table based upon that. The problem is that fields with the type list can contain a multitude of values and therefore cannot be tested mathematically. That is why Python has a special in operator. So you can see in this function they're doing drama in this list. You can see drama is one of the elements in the list. So it's returning true for that one. And then it's looking for comedy in this list. And since you only have drama, crime, and history, comedy's not in that list, it's returning false. Okay, read as the element drama is on the list sci-fi drama. This statement can only have a value of either true or false. This means the in operator and conditional constructions naturally complement each other. So you can do if crime in Birdman genres, print Birdman has the genre crime. Otherwise, don't. Okay, so let's filter the table by genre. In order to do that, write the function filter by genre. It should include the two arguments, the data table, and the name of the genre. It should return a completely new table that includes the films from that specific genre. Once you've written out the function logic, call the new function and pinpoint every melodrama film. Okay, so we're just going to repeat what they had before. We're going to check for every element in the list. We're going to see if genre is if genre in element. Okay, so it's going to loop through every list in the table. So it might grab this whole Rain Man column, and it's going to say, is the certain genre in this element? And we don't actually want to check this list. We want to check this list, which is the 0, 1, 2, 3, 4th index. So we should do element 4, right? So it's going to check every element of this list here and check to see if the genre that we give it as a parameter is in that list. Okay, so if the genre is in that element, we're going to add it to what we're going to return. So we're going to do toReturn equals an empty list. And since it's Python, I should use the notation like that. That's the variable name. And then we're going to toReturn dot append I think it wants the whole row, right? Let's see. It should return a completely new table that includes films from that specific genre. Yeah, I think it wants the whole row. So we'll do return append the whole element. Okay, and then when we've looped through all of them and checked to see if they're in that genre, we're going to return the list that we've created, which is toReturn. Okay, and then they want us to print the table and write get the melodrama category. So we'll do filter data equals filter by genre, and we send it the Oscar, what is it, Oscar nominees? Let's see what the table's called. Oscar data, Oscar underscore data. And the genre that we want is melodrama, right? Let's see. Yeah, melodrama. Okay, so let's play that and see if we get some results. Looks like it. Does it say to sort it anyway? I don't think so. We'll just check that. Correct. Next. Some genres are more common than others. Let's try to find the most popular ones, create a table, and save it in the variable genre counts. It should have 2 column genre name and number of films. We've collected all the genres in the variable all genres. First fill in the table with the data, then sort the number of column in descending order. We've already written the code to process the data in the following format. Okay, so they give us the whole table, they give us this function that's going to filter by genre, and they give us this all genres list. And we create a table list of lists, and for each genre in all genres, we're going to filter, get the data for just that category, which is filter by genre. We send it Oscar data and the genre we want, which is genre. Okay, so that's how we get the filter data for just that genre category. And then we're going to calculate the length of the filtered table. So we just do length of filtered data. Okay, and then add the genre name and results of the calculation to the table. To do this, use the function append. Okay, so what's the table called that we're adding to? Genre counts. Okay, so we do genre counts dot append. The genre name is genre. We actually want to append a whole list, right? So we need to do a square bracket, and then we do the genre as the first column, and then we do the count as the second column. Okay, now sort the table in descending order. So we do genre counts. By the way, it's outside the loop, so we've gone through all of the genres already, and so now we're ready to sort it. So we do genre counts dot sort, where reverse is equal to true. Okay, and then I think it should print it. So let's run it and see what we get. Oh, we didn't give it what key to use, right? It'll probably sort by the name. And I also have a typo, it looks like. Genre. Oh, genres count. Okay. And so the key we're going to use is, again, a lambda row. I forgot the B, I guess. Lambda row colon row 1, right? Because 0 would be the genre. We want to sort by the count, which is the first index, or I mean, guess one index. Okay, so we play. Key equals instead of key colon. It's my bad, typos. That looks right. Looks like drama's a number 1 by a long shot. Correct. Next. Multiple functions within a program. We spend a lot of time writing functions. Time for us to use them. Python allows programmers to use several functions in a single program. In the last lesson, we obtained the following results. They give us our table again. We're only going to focus on analyzing the 5 core genres. The rest are either rare or too dominant. Now let's figure out which characteristics correlate with each of the 5 genres. We already have functions that create supplementary columns of return on investment and cost per minute. Now let's add them to the output table and organize the genres better. Okay, so we're going to add the function call add ROI and then add cost per minute. Pass the Oscar data output table to both functions as a parameter, then calculate the rating, running time, and ROI and cost per minute mean values for every genre. Use the column mean function to do so. Okay, so here they had done all the functions that we've already written in previous sections. And the first thing we need to do is add the columns for ROI and cost per minute of the film to the table. To do this, use the functions add ROI and add cost per minute. Okay, so we add ROI. Let's see what add ROI takes. It just takes the Oscar data, it looks like. And then add cost per minute of the Oscar data. Let's make sure that it only has one. Yeah, add cost per minute takes just the data. Okay, then genre means, filter the table by genre. Okay, to filter by genre, we're going to call filter underscore by underscore genre with sending it the Oscar data, and the genre that we want is the genre. And we need to store this in something. Yes, we can do filtered equals filter by genre. Calculate the filtered table's means. So there should be a function for that, right? Yep, column mean. Column underscore mean, and we send it the filtered, and the column number is 2. They give that in the comment, and we do the same thing for length here. Column mean filtered 3. Column mean filtered 7. Column mean filtered 8. Okay, then it should append all of them and then print it. So let's see if that works. Seems about right. Are we supposed to sort it or anything? Doesn't look like it. I'll just check it. Correct. Next. We obtain the following results. Melodramas are the most expensive but most profitable films. They feature the biggest stars, making them expensive to film, as well as ranking in enormous revenues at the box office, which, with the massive budget and box office gross, Titanic had a gigantic influence on statistics overall. Crime films and thrillers are the shortest and least profitable. They just can't handle the pressure for too long. History films are the least expensive to produce. It's also possible that historic films have a more reliable fan base. So we continue. Lesson 12, the not operator. So I think I used this in a previous lesson that I was wrong in. But I think it was because it was worded weirdly, but we'll see. So our list only includes one film that isn't a drama. Let's try to dig it up. Using the not operator will help us accomplish this task. It can reverse any given condition by changing true to false and vice versa. So you can see not true is false and not false is true. For example, we can rewrite the function in order to check if a film is new, released after 2007. So if it's not, so first it's going to check this condition, right? Is the year greater than 2007? So let's say it's 2008. Okay, so normally 2008 would return true, right? Because 2008 is greater than 2007. But you have the not here, so it would actually return false, and so you get old films. So there's a lot of like you know how people say you shouldn't use two negatives, let's see. Like that ain't not true or something like that, or they use not twice, which would mean what it actually is true because it's double negative. It's that sort of thing, okay? So finish the function filter without genre. It should toss all the films of a specified genre from the table to the cutting room floor. The arguments of this function are the table of films and the genre that needs to be excluded. You don't have to change the output data, just let the function produce a new updated table. Okay, so we scroll past the initialization, filter without genre. Okay, let's see. If genre in genres let's do if genre not I guess you put the not before the in. Okay, so maybe we do genre in genres. That's the first check, right? You're gonna do if it's not in there, then you append it. Okay, let's see if that's right. They said there's only one film, right? And it looks like it's Chicago. Correct. Next. The and or operators. There are two additional operators used for building more complex conditions in Python, and or. The and operator combines two conditions into one, only returning a true result when both of the included conditions have been met. So you can hear they have true and true returns true, true and false returns false, false and true returns false, false and false returns false. Okay. Let's use this operator in order to find every historical film released after 2000. So you see they have to do a check to see is it history, and they also have to check is it released after 2000, so they have the and operator in there, okay? You could potentially just do two if statements like nested within each other, and you wouldn't need to do the and statement. The and statement just makes it a little bit faster, so you don't have to write two different if statements. The or operator also combines the two conditions into one. However, this structure will return true when at least one of the specified conditions has been met. So you can have true or false returns true. So you can have true or true returns true or false returns true, false or true returns true, and false or false returns false. So only if both of them are false, it will return false. Now let's search for every fantasy and sci-fi film in our table. Okay, so they write the code for that. So now they want us to write the function filter suspense that will compile the most suspenseful films, meaning those of the thriller or horror genres. The function should accept the source table as an argument, return it filtered but unchanged. Okay, so we filtered. So do filtered equals a new list, and then for each element in Oscar data, we are going to, so we have a whole list now. We need to grab the genres, which are equal to the elements. Let's see which index character. 0 is the title, 1 is the year, 2 is the rating, 3 is the length, 4 is the genres. And if, let's see, thriller, let's see, if thriller in genres, or, well, we'll put parentheses around this just to make it clear. You don't have to. So that's the first condition, if thriller is in the genres, or if horror is in genres. Then we want to append element to filtered. Okay, and then we want to return filtered. Okay, let's see if that works. Let's see. Check it. Make sure a filter suspense function runs when the right condition is met. Oh, thriller and horror genres. Okay, so I'm using the wrong keyword here. We should have and, not or. It's like only Silence of the Lambs, huh? Interesting. The most suspenseful films, meaning those of the thriller and horror genres. The function should accept the source table as an argument and return it filtered but unchanged. Second, but I figured it out. The reason that it wasn't working is, for one, I had the list up here as Oscar data when it should have just been data here. So we shouldn't be using the global variable. We should be using the parameter that they send us. So originally I had Oscar data here. Now it's just data. And in addition, it was supposed to be or instead of and. So I just switched the and or, ran it, and it says I completed the task. But again, I think it's just because their description is a little weak there. That's why we couldn't get it right off the bat. Okay, so now we go to the second question. To analyze films by their years of release, we must first learn to delineate ranges from the table. For instance, from 2000 to 2010. Write the function filter first decade to filter the table by the aforementioned condition. The function should accept the source table as input and return it filtered but unchanged. Okay, so we go up here and we do the same thing we did before. We do filtered equals an empty list, and then for each element in the data, we are going to grab the year, right? And so the year is element at, so 0 is the title, 1 is the year. Okay, and so we're going to check if the year is less than 2010, and year is greater than 1999, then we're going to append the element filter.append element. Okay, and then we're going to return filtered. Okay, so if we play that, and check it, okay, so it's probably like either supposed to be less than or equal to or something like that. Let's see if they give us an example here. (2000 to 2010). So maybe do greater than or equal to 2000. And it has to be less than 2010, right? Because that would be the second decade. 2010 would be the second decade. So let's try that and see if that fixes what they're not happy about. Nope. I just played around with the greater than or equal to or less than or equal to conditions, and this was the one that they liked. It doesn't make a lot of sense to me because 2010 seems like it's in the second decade, right? So I don't get that one, but that's what they wanted. So next. Okay, abbreviating conditions. Before moving on to analyzing the films by year, let's take a look at some of the convenient ways to abbreviate our coding. First, let's try to write a function that will place films into one of three categories: short, medium, and long. This code has a nested condition. We can simplify it using the keyword else if. So you can see the elif condition. So it lets you basically do a third condition on top of just if or else. And the condition length is less than or equal to 130, and length is greater than 120. Can also be abbreviated as 120 is less than length, which is less than or equal to 130. In the end, our function is going to look like this. Okay, so now they want us to filter by year. To select films according to the year, it should return a table of films released within a specified year range. Data about the film and limits of the set period serve as input arguments to the function. Films released in the latest year of the period should be excluded, whereas those released in the first year should be included. This is done in order to ensure that no periods will overlap. Use abbreviated coding for your conditions. Okay. So we do We're going to do filtered equals empty list. And then we're going to go for elements in data. So we're going through each list of the table. We're going to get the year for it, which is the like one index, so it should be data or element at 1. Okay, and so if the year is so I guess we do begin is less than, let's see if it's less than or equal to, films released in the first year should be included, so less than or equal to begin with year, which is then less than end. So if that condition's met, and we can put spaces around it because they like to not make it look so clunky, then we can append it to filtered. Okay, and then we need to return filtered. Okay, so if we play and check that, let's see, typo somewhere. Should be an L here. Okay, check that. Correct, next. Now they want to pull everything together. We obtain the following outputs. The film production is in a downward spiral, however, that should be short-sighted theory as we haven't properly considered the context of time period and market economy. A more accurate hypothesis would be that the Academy is moving away from preference for commercial successful films to what is commonly referred to as festival pieces. Okay, so you see more box office grosses from 1988 to 1998. Okay, and then they have the conclusions for the data here. Oscar-winning films are becoming shorter, cheaper to produce, and their box office profits tend to be dropping as well as ratings from viewers. Their preferences are shifting towards artsy films and away from money-making blockbusters. Melodramas are the most expensive and profitable genre, stemming from its innate popularity and outrageous cost of casting big-name actors. Titanic has greatly impacted the stats. Crime films and thrills are shortest films, which earn the least amount of money. What's next? We're going to talk. Our first business task will mirror the real life, analyzing data from Yandex Music and conducting experience provided by this service. You'll become acquainted with the Pandas library and will allow you to advance from the training table. So with that, that's the end of this lesson. We finish this module. So thanks for watching. See you next time.